X cos in SCILAB. This X cos, it can be used for modeling and simulation of various hybrid or dynamic system. If you heard about the control system, and in control system, we have process control. If you want to control a certain process, you always apply certain dynamic system. So to model those dynamic system, we can use to model those dynamic systems using X cos and simulate it, whether we have obtained the desired result or not. I will take a few examples just by creating models and then simulate it and check whether we have obtained the desired result or not. So to model a particular block, suppose I want to display a sine wave. So to display sine wave, we required something to display, and in sync you will find all type of display. And each and every display has unique function and unique features. So if I want to select this one input, C scope, just select it, right click and drag it. Sorry. Undo. Now it's drag. So just select, or you double click it, add to untitled, because I have not saved this file or this model. So if you double click, it can be transferred also. It is up to you whether you drag it or you double click this, add to untitled X cos. If you require to, you can, or you can also create copy and paste again. It is up to you. If you require 3 C scope to display your result, just drag one and then cut, copy, paste. Now I required a source such as sine wave, and if you check, here is generate sine function. I will just drag it. And now you need one more thing, that is clock. This I don't require. I require this one. Now to connect, just set your cursor here and connect it. If it is wrongly connected, you just connect it. Now, if you double click this function, you will receive the properties. Amplitude, if you want to give amplitude 3, frequency 2, and phase in radians, I will not give. Now, if you double click this C scope, you will get a lot of properties there. Curve style, color, output window number, output position, y-axis, Y mean, Y max, refresh period. I am putting this refresh period as 20, buffer period as 5. Similarly, if you double click it, you will receive period and initialization time. If I put this initialization time as 0, now you go to setup. Here you have given time period 10, refresh time as 10, so I make it 10. And now to save this, give number 7. I have given 7 number, and now run it. Here you have received a sine wave. This is simple program. And now if you go to axis property, you can change. It will take some time, just wait. In between, if you wish to change this, suppose you say it is my time, you just time. And if you say it is amplitude, you say amplitude. And if you want to change property, figure properties, you can change from here. Graphic window name, figure name. If I go to axis, here you have x-axis time, y-axis amplitude. If I change it in caps, title, I have not given any title. You just give my first expose model. You can change back color and other things also. It is up to you. You can also change the font style. If I say bold and italic and I say quit, you say check it here. Title is there, my first X model, time, amplitude, and if you want to give grid, option may be there. Can you check where is grid? Grid color, we have not check grid. Ticks, step size, yes. Insert, width. This is step size. Now you can check whether the frequency is same or not, whether it is exactly. You can also change the style of this line also. It is up to you. By changing axis property, you can change. Polyline, is there anything more? Arrow size, solid line, you dash, okay, and you check it. And position or phase will also change. So in this way, you can design your model also using Xcos. This is a simple model of displaying sine wave. Now, if I close and put CLC here and again open Xcos, now you know the formula of kinetic energy, which is equal to 1 upon half ME M into V square. Now, if you want to implement this equation using Xcos, what type of blocks I have required? Can anybody tell me? What are the various blocks required for this?
Parabola.
What, madam?
The parabola.
Please repeat.
The parabola.
He
is saying that parabola.
Parabola, it's just I want to create a model for this equation, which is half of M, that is mass of the body, and V, kinetic energy. This is for kinetic energy, which is the formula is 1 by half into M into V into cap, square for cap. This is the formula. Can anybody tell what are the various things I will require to create a model for this equation? Or what are the... Now tell me, what are the various palettes we need it to create the model for kinetic energy. Just wait, I will open. I have to check which model is there for... Yeah. It means I have supplied something from workspace. If I double click, you can see here variable name, that is velocity, interpolation method 1, use zero crossing 1 for yes. Yes, I am using. Output at the end, this. I have changed this only, this velocity. Either we can take V. Now here, I am taking the variable name as velocity. Then this is nothing but it is the power function. And you can find here power function somewhere in mathematics. This one. This is power function I have taken here. This is the product. Number of input or sign vectors. Multiplication is set with +1, division with -1. Here, all three variables I am multiplying. 1 by half, I will check it. 1 by half, it should be 1 by half. It should be, mass should be 1, and velocity. So if you want to put multiplication sign, it should be 1, and for division, it should be -1. But here, all the terms, they are product. So I have put it +1, +1, and +1. And I have three terms, 1 by 2 into mass into velocity. That's why I have put 1 for half, m for 1, and v for 1. So now this is the value of constant. I will put 0.5. I will delete this. Mass is 1. Set constant value 1. And here I have to give this from console with respect to time. At this time, velocity is this. At this time, velocity is this. At this, and so on. And again, this is nothing but it is the cos scope. This is the clock. And you can find the function of what is the function of clock, what is the function of scope. Scope is only to display the result, and clock is for clock event. Now type velocity dot time is equal to length space 1, 100, 100. Again, I will put velocity dot values is equal to length space 1, 100. This. Now if I run it, data bounds value must be finite. Data are inconsistent. Variable size is log output 1, 1. It should be V. This model is correct. Just cut it. Copy. Now I will change the velocity to 2. So 1 by half into 1 into 2 square, that is 4. It should be 2. And to display this constant, I require a constant block. It should be in sync, sorry. I will use this, remove this, connect. Now it is connected. You just run. What is the error? Cannot open local temp file. Why? Struck, it was generated. Okay, sorry. I have to change the directory because D3. प्रोग्राम यही चल रहा है भाई, डायरेक्टरी तो सेम है भाई. चलिए, I will close. I will check it. Let's redesign it. I don't need this block. Constant, try to find this constant block, this one. Copy, copy. Make it 2.5. Mass is 1, it's fine. Velocity set constant value is equal to 2. Find this. Now 1, 1, 1, 1 means all are multiplication factors is incorrect. Answer given for number of inputs. Sorry, it should be semicolon. Now it becomes 3. Make it large. Connect this. Connect this, and it should be power. So I will use a power product somewhere. Power block. And power should be not 1.2, it should be 2. Connect this. It is already connected, so cannot open this. Why it is not opening? Say number 8. Expose. Okay. What is the problem? Why it is not opening? User C data. If we have to take care for day 3. Now just try to run. Again, same error is there. Blocks are correct. All blocks are correct. Something is wrong. It might be possible that sync we have taken this. It's fine. Everything is fine, but it is not opening. That's why either D drive, workshop, present directory is also same, but it is not opening. That's why Just wait for a while. This is the last attempt. I am going to do it. Owner file not opening. Why? Just wait. I will open it again. I think something is wrong. Either I am not providing the exact path or models are verified. I have checked it. Everything was fine. Just wait. It's fine. Uh, can you predict what is the model for a particular system? I have designed a model for a particular system, and this is the response of that particular system. Can you predict what is this system? Anybody? Anybody can say? This is the step response. This is the step response of second order system. So second order system response is this one. We have already studied in literature If you have a second order equation, you can find the step response, you can find the sinusoidal response and other types of response for various inputs such as sine wave, step, and others, ramp. So this is the system. Here I have used a ramp signal. This is again a multiplier where I have used set simulation block parameter, number of input or sign, +1 for plus and for -1 for minus. So this is a summer, means summations is there. This is a gain block. This is the integral block. We have many type of blocks are there. One is integral. We have also a differentiator or derivative block is also there. Here we have used mux to display the input, that is step signal, as well as the output of this second order equation. And it should be displayed on a single scope. So if I change the initial condition, final value is 1, step time is 1, and if I say this value is 2, initial value is 0.01, you can change and you can run it now. You will see little bit variation is there. One more thing I want to say that we can use is set context. If I double click here, I will say here M is 1, constant C, which is a type of constant. If you are using second order equation, you will find that the motion should be underdamped, overdamped, critical damped, and so on. So you have to put the constant value, that is damping ratio or damping constant. One more is there, I forget this C. This one I have set here. So it is, this is constant C, this is K. That's why it can also be in numbers also. If I say it should be 0.3 or only 3, you can put it 2, you can put it, and from here you have to remove all this. You can put M1 here and still you can run it. You can find this response. So it is up to you. So if you don't want to use this as a constant value and you want variables, then give this variable name as K, this one as C. You can give any name, it's hardly matter. Gain K. Why it is? Because just wait. Set contest, M is equal to 1, C is equal to 2, and K is equal to 5. Put. Now if you change, K is equal to 3. First we have to define their simulation set and set context. And now if you run, you can run. So if instead of sine wave, if I use instead of step signal, if I use sine wave, and run it, not enough information to find the port size. What is the size of this link? Here it is still it is showing some mistake. You can try, but the syntax or the modeling type will remain same. The only requirement that is you should know what type of blocks you required and how these blocks should be connected, whether we use summation, whether we use product, whether I use marks or demarks, whether I am using gain or anything other things. That should be required. It should be kept in mind. Try to find the blocks, drag and drop it in the location or in the window where you are creating the model. Connect all these blocks, set the parameters according to your requirement, such as for the scope, for clock, and from here you can also set the set parameters. Final integration time, if you see here, it should be 3 raised to power 1, 3 into 10 raised to power 1. And if you check here, it is again 30. So it should be same. And if you go to the clock, you can increase or decrease this time. But the simulation time of this refresh period and the simulation setup time, that is final integration time, it should be same. That is the requirement. Now the last thing that I would like to share with you, the most important one, this user defined function. This is user defined function. If you want to create this type of blocks for your utility, you can create. You just check where is this, try to find user defined function. This one, connect here, make it large just by clicking zoom button. Input port size 1 that means you have only one output input and one output. If you put 1 it means you have two input. If you put 1 it means you have two output. आपके जितने भी आउटपुट होंगे you have to mention in this fashion. And similarly I will remove this because I am creating only for one input and one output, so it will remain same. Now here you have to give the name. I am giving it square it and okay Okay. Okay. Now it's fine. Where is sign? I want to plot the I need a clock also. I will require now I think everything is corrected. I will display box should be there. Now I have done. Now I go to sign out. I have already written a function y is equal to square it a, and output is y is equal to a square. Now I run it. You will see two things here. It is the square. This is the sine wave that I have provided with amplitude 1, frequency 1, and here I have find the square of this. So in this way, you can configure your own user-defined function. It is up to you. If you want to configure a user-defined function, in this way you can define. First, you have to set the properties, how many number of inputs, how many number of outputs are there in the function, and then you should write this function with number of inputs and output. Name it the same as you have given in the model name, and then run it. You will see so in this way you can create your own model. If you are a faculty of electronics and communication, I think you have heard about PID controller, professional profess, pro, proportional integral derivative, that is PID, which are used in industrial process control. We can also model it using this XCOS. I don't want to save it. No. And one more thing I want to discuss is, if you want to install a particular toolbox in SCILAB, such as image processing toolbox and other types which are present, just go to application, select module manager items, click take time, and from here you can select any of the toolboxes, that is bioinformatics, data analysis, data handling, documentation, education, graphical user interface, graphics, graphs, image processing, manuals, modeling, number theory, numerical methods, optimization, parallel computing, physics, SCILAB development, signal processing, technical, Windows, and XCOS. Suppose I want to work in image processing. You select image processing, then you select this image processing and computer vision toolbox. As I have already installed, that's why this is inactive. I have already installed the image processing and computer vision toolbox. That's why it is showing uninstall install button as inactive. So now write your file. I will remove it. I want to open a certain file. You just check whether it is. I have taken a image of baby with image format as BMP. As you are aware, you have number of formats for displaying image such as BMP, TIFF, JPG, JPG, and so on. Yes. Hello.
వాళ్ళకి వచ్చు నిన్న రాగానే పెట్టాడు
So I have written a few lines to read a particular image. I am using a command imread. To display the image, I am using imshow. To convert the RGB image into grayscale image, I am using RGB to gray. And I am also plotting the histogram for a particular image, and I am using the command imhist. So if I run it, you can see this was my original image. This is gray scale image or gray image, and this is the histogram for a grayscale image. You may also design filters. If you are a student of image processing, you can perform any type of operations on a particular image, whether you are using filtering, whether you are using spatial filtering, or any other type of operations, whether you are making negative image, whether you are cropping the image. So each and every thing that you want to perform, you have to use certain commands. And in image processing, these are the few example of few. And if you want to, I am right. Now I can write a particular image with certain extension and other things. Save and execute. Now my image is saved at somewhere in the directory. If I go to undefined file name 12, it means I have to provide the location also. So, but the command is I am right, that is fine. I have to write certain locations where I want to write this image and so on. That's why it is showing some error, but the command is I am right is fine. So you can also use this image processing toolbox for performing various operations on image in SCILAB also, which you have done using MATLAB. So this is all about today's lecture. If you have any question, you can ask me. Anybody want to ask certain question?
Yeah, I think no one, sir. Dear
Okay.
participants, if anyone have doubts, please raise a hand and you can ask. So we'll wait for 2 minutes, sir, and we'll close the session.
Okay. So these are the slides I will share with Vinod sir.
Sir, also third day and fourth day also PPTs if you send, I will forward.
I have already sent to you, sir, third and fourth day.
No, so only up to 2 we got, sir.
Okay, I will check. I will check
Okay.
and send 3, 4, and 5th day.
Okay, sure, sir, sure. Yeah, 3, 4 I got, sir. Okay, I will forward.
Yeah. These are the various plates
Yeah,
which
3,
are
4,
present inside this. You have got now?
Yes, got, sir, got it. No.
Okay, okay. Sources, steps for creating models, clock, function of each. In help, you will find each and everything about these blocks, or sometime in SCILAB it is called palettes, whereas in MATLAB it is called blocks. These are the few commands: IMSO, conversion, cropping, and so on. I have not covered this lot of things in image processing because it is a time consuming process and it requires lot of time. If you practice, you will definitely got it, and it is up to your hard work how you will learn the image processing toolbox, how you will learn to design your own model or your own user defined functions or blocks in Xcos. So that's all from my side. Should we end the meeting, sir?
Yes, sir, we can, sir. Okay, sir. Thank you very much, sir.
Okay, sir. Tomorrow at same time I will be there, sir.
Same time, sir, tomorrow. Dear participants, tomorrow also
Okay,
same
sir.
time we will start and finish the session. Thank you.
Okay, sir. Thank you.
Thanks.